So we'll be discussing how to draw patterns programmatically. So this thing I just edited is called Markdown in Jupyter Notebook. Markdown. It's used to provide comments and documentation to what you're doing. So it is quite different from the typical comments that start with a pound sign, pound symbol. So it's quite different from that. So take notes. Okay, so since loop allows us to do the same thing repeatedly, we can actually alter some of the functionalities or some of the actions that take place inside the loop. And using that approach, we're going to draw patterns programmatically now. So the first we will be seeing here is a triangle. So what is happening here is this triangle allows you, or let me say this code allows you to specify the size of your triangle, 7, 8, 20, and it draws. Okay, so 20 because of the width, it couldn't format it properly. Can everybody hear me, please? Can everybody hear me?
Yes.
All right, thank you. So because 20 is too wide for the screen, so it reformatted it here. So let me reduce it to say 15 and see how it looks. Okay, so there you go, 15. Because you can specify any size for your triangle and it prints, and it prints it out. So what we are doing is having specific. Okay, let me start by saying, in order to do something like this, to draw any pattern for that matter, you first must understand how you can break this down in such a way that the repetitive actions can be captured. So okay, let's look at this. I know the first line is just 1 star that I need. And the second, I need 2 stars. The third, I need 3 stars. The fourth, I need 4. And it goes on and on and on. So that seems like a pattern that is repeating itself. And it makes it easy to find a way to define the statements inside the loop that would mimic this pattern. Okay, so now what I did is for the first line, I simply printed it here. This is what is happening here. The first line, I simply printed it. For the subsequent lines, so I'm now formatting it. I think it may be quite difficult to explain it within this time frame. But know well, by the time you get the notebook, you get to play around with it. Let me comment out this first line and let's see what gets produced instead. So this is what gets produced when I remove the first line. Let me use a smaller size. Okay, so this is what I get when I remove the first line. But returning it back, it produces what I want. So if I remove the second line, let's see what happens. Nothing happens. That tells us that the second line seems to be doing bulk of the work here. That's where the main. So let me remove the third line. Okay, so removing the third line, we see a messed up structure there. So each of the line has what is contributing to it. A good way to go about such problems is to at least first start looping. Start looping and start putting a start. So let me do something. Assuming I want to recreate it, and I set my n to say 5. So I can say for I in range 5, for instance, print star. Sorry. Print star. And I get this. Okay, so I can now say, okay, this is only printing it once. I want to print it multiple times. Remember, you can multiply strings in Python. So let me say multiplying it by 5. It prints something like this. Not quite what I want, but at least it's a step in the right direction. So what I probably need to do here is put space in between these. So what if I put space here and still leave the 5? I get something like this. So if I look at this now, I can think that, okay, what if I just remove the edges, trim out the edges? How can I trim out the edges? Okay, so, okay, before trimming, okay, yeah, let's just trim out the edges. So instead of printing 5 each time, I know the first line only needs 1 star. So how can I print just 1 star here? Remember, I'm using a for loop to loop through it. And this for loop gets a virtual list that starts from 0, right? So what if in this virtual list, instead of multiplying it by 5, I just multiply it by I plus 1. Sorry. By I plus 1. Well, I think I'm quite close. You'll agree with me. So you continue to do it iteratively until you get what you want. Most of the times, if you are given such problem, there is no way you can just approach it without starting to at least do it iteratively. You do something, see what it gives, except, well, probably if you're very proficient with it, or if you've understood how that particular pattern works very well, you can simply start writing it. But if you look at what I have here, and take note, there is no one way to achieve a result like this. Most of the times, if you give it to 10 different programmers, they will give you 10 different approaches. You might have 1, 2, or 3 that will be similar, but you're still bound to have so many that will be similar. So just deleted one accidentally. So you can undo any cell you have deleted. I just did that. Okay, so going forward, so what I created here is what we'll be doing here. So creating, okay, so not this yet, not this. So here we're creating an inverted triangle. The same thing we did here, we're inverting it here. And there you go. You can also specify any value for this n. And you get the same thing. Also note that this asterisk I'm using can be anything. So I want to change it to pound, and it still works. I want to change it to ampersand, and it still works. So now let's see how to make a pyramid. A pyramid is basically combining this first triangle and this second triangle. So, but yeah, it looks like it's quite easy, but sometimes it may not be as such. So this one is quite straightforward. I just brought the two together and I ran them together. So I can change the symbol it is using as well. So I get something like this. So you can play around with it and see all the different things it can produce. So now another pattern, letter H. So letter H, You'll also get a chance to play around with it to understand how it is working. I can change it to, I can use H to print H. Sorry, I'm missing something. I can use H to print H. I can use anything, like I've said. So we get a chance to play around with it. Okay, so Pascal's triangle. Now, these are another interesting mathematical concepts. Pascal's triangle, and it's quite useful for solving binomial problems. So you can easily generate your Pascal's triangle with Python. Oh, sorry. I think, okay. So this, we're on this line, on this code cell, and not Pascal's triangle. So, and this is letter A, generating letter A programmatically. So remember, you can also change the values here. It can be 18, still works. So I added the time function to make it a little bit interesting to watch as it loads. So going further to Pascal triangle, I have a code here that generates Pascal's triangle. If I want to generate it slowly as well, I can do that here. So this Pascal's triangle, if you don't know how it works, you can check Wikipedia or any online resource that explains how Pascal triangle works. Okay, so here we're going to condition controlled loops. Time is fast running out. Okay, so count condition controlled loops. So this is a loop that is controlled by a condition. If the condition is true, the loop continues to execute. If it is false, the loop stops. So let's go into it. So here, as long as this list is not empty, continue to run. So that's what we have here. While items, implicitly, Python checks if it is empty or not. If it is empty, it returns false. If it is not, it returns true. So let's see. So if you remember from the second class, we discussed some methods of lists, methods of the list. So one of the methods of the list we discussed was pop method. This method is used to remove items from the list one after the other. You can specify the position you want to remove it from, or you can choose to remove it from the end. So not specifying anything here means that it is removing it from the end. So it removes each and it prints it out until the list is empty and it stops running. So here, let's see another example. So this loop executes as long as this num here is less than 15. The moment it becomes greater than 15, it stops. So we are initializing the value of num to 0 here. If you don't initialize it to 0, this is going to throw error because you wouldn't have assigned a value. So let's see how it goes. I think there's an existing value for, let me set num. Okay, so when you try to run it without having set a value for num, you're going to get type error. This not supported between instances of non-type and let me instead delete it. Trying to delete the variable num. Yeah. So I've deleted it. So trying to run this, it tells you name error. Num is not defined. So that's why you have to first define it and set it to the minimum